Hello, Patrick. Thank you for taking the time to speak with us today. For those that don't know you, can you please introduce yourself?
Sure. Thank you very much. My name is Patrick Mercier. I'm a professor at the University of California, San Diego, where I co-direct the Center for Wearable Sensors and the Power Management Integration Center. My research is on wearable sensors and power management ICs, as well as low power wireless circuits.
Fantastic. It's a real privilege to have a leading research expert teach our upcoming online course on energy efficient analog IC design. Can you please share with us some of the main highlights of your exciting course?
Sure, absolutely. So a lot of modern applications for things like Internet of Things, wearables, or even many components in cell phones and so on, data centers and so on, they're requiring increasing levels of energy efficiency. This is, obvious when you have battery powered devices, but even in data centers, these things consume so much power that any little thing we can do to help improve efficiency is going to have a dramatic impact on the overall cost and workability of these sort of devices. So this course is really architected to give a good overview of a bunch of different low power and energy efficient design techniques. We'll start with a brief overview in subthreshold design, GM over ID design methodology, and things like this. Then we're going to move on to some basic building blocks that really leverage good subthreshold design practices, reference generators like voltage and current reference generators, oscillators, and things like this, all that are temperature, process, and supply voltage stable. And once we have those fundamentals, we'll then move along onto sensors and sensor interfaces. We'll include things like electrochemical sensors in our discussions there, which might be new for a lot of people who are taking this course. We'll then have a lecture on instrumentation amplifiers. These are important for electrophysiology sensors and other high impedance sensor interfaces. So that'll be a very nice lecture. We'll then move on to a discussion of low power ADCs. We'll focus mostly on SAR ADC design techniques, but we'll talk a little bit about some oversampled converters as well. Then we'll move on to wireless transceiver design. We'll focus on low power LNA design, low power design architectures, wake up receivers, and so on, and talk a little bit about power amplifiers as well. And then we'll move on to low power PLL design techniques, how to do frequency synthesizers or LO generators very efficiently with the best figure of merit possible. And we'll finish the course on a discussion on efficient DC-DC converters.
Sounds really fantastic. Can you please comment on how this cutting edge course meets the current demands of the semiconductor industry?
So, as part of my centers, we talk to a lot of industry members and a lot of customer demands. In fact, in many application areas, the number one customer demand is low power or energy efficiency.
Mhm.
And, when you go through your traditional senior level undergrad and grad level courses, they're more focused on fundamentals of IC design and less specifically on low power techniques. So the things that we'll talk about aren't generally taught in IC design classes. We're going to leverage a lot of work that's happened in my lab as well as throughout the literature to show kind of key design techniques and examples on how we can achieve this low power or energy efficient operation that will, help in many of your designs. So industry professionals working in analog, wireless, or power management circuits should benefit from our deep dive discussions and design examples.
Excellent. Speaking of your lab, could you please tell us what technology nodes do you use for your research activities and why?
Yeah, that's a great question. Most of our power management and some of our analog circuits are actually still done in 180 nanometer power management, particularly in a high voltage BCD process, just so we can process, more than 20 volts.
Sure.
And the reason we use those is, they have high voltage options, but also they're really good for analog design and they're cheap and have frequent tape outs, right? But I would say most of our designs are happening in the 65 nanometer process node. This is kind of more where we do our wireless activities, as well as we do tape out quite a bit in 22 FDX, And we've done some FinFET tapeouts as well, but most of it is centered around that, I would say, 65 node.
Okay, fantastic. One last question, Patrick. In your opinion, who is this course for?
Good question. So the course is targeted more towards those who have experience in analog design. This is not for beginners, but they want to get a better understanding of the wide range of techniques and design styles that help towards achieving low power and or energy efficiency. So there's no silver bullet in this area. You can't just, wave a flag and immediately get low power. It's always an exercise in trade-offs. And so people who want to better understand that exercise would benefit from taking this course. Specific experience in wireless or power management circuits are not required. We just want people who are generally interested in analog design, and I think they would get a lot out of this course.
Thank you so much, Patrick. We are eagerly looking forward to your course in January. Thank you.
Thank you very much. I'm looking forward to it as well.